All right, today's lecture we are going to be talking about 2D machining, what used to be referred to as 2.5. So we'll talk about some of the different tools in Fusion that you can use to start writing your program, and some of the most efficient and effective machining practices here in CAD. So right now I've got a part that I drew up. I'm in the design workspace, so we're going to go ahead and go into the manufacturing workspace. Now, of course, you guys recall we would need to go in and set up this particular part here first, so we'll come back at a later date to do that. I just want you to kind of understand some of the different machining practices that we're going to be looking at. Now, as you take a look at the top panel bar, so we do see these different tabs in the manufacturing space. So we've got the milling tab, right here is the turning tab, we've got an additive tab, inspection, fabrication, utilities. So we're going to be concentrating here in the milling tab today and taking a look at these 2D machining practices here. Now, mastering this 2D machining practice is, of course, one of the most essential skills for anybody in CNC programming. These are definitely the foundational operations for material removal. They're very, very important for us to understand exactly how to use these tools, and the simple way of using these. So sometimes we might just use these different types of programming tools to square up a block, or we might need them to actually cut and be much, much more precise in terms of different types of interior or exterior profiles that would be putting on a part as well. So we want to get a pretty good understanding of what all of these are. Three most common 2D profiles that you'll be using the toolpaths are going to be what we refer to as face, 2D pocket, and then 2D contour. And these are very, very important. So when we're talking about these, we're really going to be talking about some of the most efficient ways that we can remove material at certain speeds. Again, remembering and always paying attention that we want to make sure that we are removing this material as quickly as possible with different types of cutting tools that we're using, as well as making choices of how we're going to actually approach the part and machine it to get a good result. Now, when I'm talking about these, I want to kind of reference, even though we are referring to these as 2D operations, they are in reality working in three-dimensional space, i.e., we're more or less working in the X and Y coordinate, but then we also have to visualize the Z depths and how far down tools would need to go into the material in order to control how that cut is actually made. So while the term kind of refers to 2D, it's really kind of talking more about how we are generating either flat geometry or features that don't necessarily require a huge amount of surfacing or multi-axis movement. And again, these are very fast, quick, efficient ways for us to remove material. Going back just as little as 20 years ago, these were the most common, and it was very, very complicated to do other three-dimensional type moves that we'll talk about in later. So especially when I first started programming, these were pretty much the only tools that we had in our toolbox to be able to use. Now, as you consider this, so 2D operations, we do have to be very, very aware of the initial setup and certain roughing phases where we're going to rough material, maybe have to leave certain material on there for finishing or to come back with finishing as well, and then tie things in and blend materials together as well. So one of the nice things about these 2D operations is they are fairly simplistic. So they are fairly quick to calculate, easy to simulate, and of course efficient to execute on a wide range of different types of machines. They're also much easier for the operator or the CNC machinist to kind of understand and relate the coordinates and the numbers with the actual movement that the machine is making, so they can be better prepared to anticipate the movement and understand what's going to be going on there as we run a program. So the first one that we're really going to talk about here, that's kind of the beginning where everything happens, is what we refer to as the facing operation. So this here is the facing operation that we would select. So by clicking on it, we'll go ahead and so you can see what opens up here on the menu. So when we're talking about facing, we're typically using this as a first machining operation applied to the workpiece. I always kind of say in the past classes where this is what we use to establish Z0 on the part. So, and as we take a look at it, it removes material very fast and very efficiently from top surface areas. So we use this to establish a reference face or a true Z height as we kind of go through there. It's very essential for us when we're working with raw or even uneven material to use this to kind of set the stage, so to say, for accurate cuts and future tool paths. And of course that also controls and could control depths of cut and other operations as well. So that's kind of what we're looking at in terms of facing. We'll talk more about the tools and all the feeds and selections and what's going on over here a little bit later when we get into that in more detail. The next operation here that we're going to talk about is the 2D contouring. So here's our 2D contouring tab. So contour toolpaths are typically used to cut alongside, on the outside or even inside edges in geometry. So think back to when you guys were writing your program to come around and side mill. So that's where we would be using this contour milling. So the face mill on a part like this, if this were the way that we were machining it, we would come in, we would face mill off the top, then we could kind of come in with a side mill, and we would side mill around the four sides of that part. So, and that's what we would refer to as a contouring toolpath. Now, doesn't always have to be around the outside edges. It could be inside geometry as well. Edges, it's going to follow whatever the selected profile is on that. So we can define contours by the outer shape of a part. So we can trace internal walls, maybe even some of the trim features. So, and these contouring toolpaths also will allow for tabs, multi-finish passes, precise corner treatments. So that often makes this type of a toolpath selection ideal for completing final shape of any component. So let's go ahead, and I'm going to cancel out of that. So the other one that we would be referring to here and looking at is what we refer to as a 2D pocket. So pocketing routines are going to be on the inside. So any type of shoulder. So we might also kind of refer to this there as we're looking into the slots or grooves. You know, think about any of these type of issues, although pocketing may or may not be the best way to do a groove. So we'll get more into that, and we'll talk about some different ways as far as our strategic plans. So let's go ahead and head back over to the face milling again. So as we talk more here about face milling, you know, some of the successful CAM strategies here is to start with some of the largest cutting tools that you have so that you can minimize the amount of passes that might need to be taken. So we got to face that off. So there's a sequence here that needs to be followed. And of course, if we follow correct tool feeds and speeds and sequence, that's going to lead to longer tool life, less machine time, and of course, final part quality there as well. Continuing along with facing, it's often the very first operation performed on a raw piece of stock. So the purpose for facing is to create a flat, clean reference surface on the top of the material. It's very critical, and not just for cosmetic reasons, but for establishing an accurate starting point for all of our Z depths. So in CNC machining, the top surface, if it's uneven or tilted, so it can kind of mess up all future features, and it can certainly affect how we're holding the part for future operations as well. So bear that in mind. When we go to set up for a facing operation, so the facing toolpath can be created by selecting either the whole face itself. So as you take a look at this, we can kind of select that whole face, or we could select this face, depending on which side of the part we're actually working on. Once we've got that selected, then we would define the tool, geometry, heights, and passes. So, and in that selection, it is typical to select the largest cutter that you have. Now, you guys probably know by now these type of facing cutters are generally some type of an end mill or an inserted cutter. Large shell mills, again, when we're facing, we generally want to select the largest tool that we can so that we can try to minimize the number of passes that we have to take. So now, facing is usually performed either with that flat end mill or facing tool, and we try to keep the largest diameter so that we can minimize the number of passes. Larger tools definitely clear material much faster and produce a smoother surface, so if they're used with proper step overs and feed rates. Cutting strategy can be set either to zigzag or a one-way pass. I'm not a huge zigzag fan. When I program, I will tend to just do a one-direction pass, especially if I can get a shell mill large enough where I can just take one pass all the way over. Sometimes, and you guys know from experience in the lab, sometimes we'll machine in one direction, move over a little bit on the Y, machine back in the X. So that's another strategy. You could kind of say that's a zigzag in the X and Y. So sometimes people will zigzag across this way. I tend to zigzag along the longest dimensions as opposed to the shorter dimensions as far as that tool strategy goes. And when we talk about tool strategies, we can also now talk about cutting strategy definitions as well. And you will see as we take a look, here's our speeds and feeds. So we're going to kind of talk a little bit about some of this. Here would be geometry for us to select the contours. Let's just start back with the tool. So we can select the tool, and everything there is our feeds and speeds are put in that. We have geometry selection right here so that we could select where we're wanting. This would be how we would establish the heights that we want to go to that tool. So we have number of passes right here. So notice there's a step over put in this area right here. So, and a step over is just the lateral distance between the two tool paths. We have what we call a step down. So let's take a look. So that step down is more of what we refer to in terms of a Z depth, where we're not typically relevant to facing all the time, but sometimes material can benefit from this. So, and oftentimes, especially if we got really, really heavy cuts, we might want to take multiple depth passes to remove that material. So, pass direction and angle is also very useful, especially if we have to consider grain structure or layers with different types of material as well. So you got to be mindful of those types of cutting strategies as well. Remember, if we can, obviously what we're trying to do is get a finished part with as best of a surface finish that we can. But all right, a couple of tips for better face milling here is to leave a small amount of stock to leave if you're planning to do a finishing pass. Use climb milling for better surface finish, so especially on aluminum and softer metals. So as we always will simulate your tool path to ensure that there's no over travel or collisions with that either, especially when we do have a wide tool that's very, very close to the work holding device. Of course, once we execute this program, the face surface will provide us with a perfect foundation where we can do the rest of the machining from. So, and it's very, very important to understand how we can use that to impact what we're going to be cutting and get us to a good starting point to be successful with programming the part.